All right, ladies and gentlemen, boys and girls, welcome. Today we are going to talk about our second type of chemical bond formed between two atoms, or as I like to say, that relationship that two atoms can form to do that. In a previous one, we talked about ionic bonding, which was a very healthy relationship in the fact that both atoms got fully what they wanted. We had a nonmetal and a metal. Metal wanted to lose its electrons, and nonmetal wanted to gain. Both could do exactly what they wanted and thus formed a very, very strong ionic bond. Ionic bonds are very, very strong and very rigid because both things got exactly what they wanted. It's a strong relationship. Everyone is fully happy in that relationship. All right, today we are going to talk about our second type of bond here, and that is a covalent bond. All right. This one is actually a lot more prominent because a lot of the more basic elements, a lot of the smaller elements that make up our universe, like hydrogen and helium and carbon and nitrogen and oxygen, are all non-metals. All right, so this one is actually a lot more predominant, especially when we talk about biology and talk about life. It's mostly made up of bonds of covalent bonds, which are not quite as strong. We'll talk about that why today. So make sure you have out your handy-dandy notebooks. Let's talk about our second type of chemical bond here. All right, our second type of chemical bond is called a covalent bond. Well, first of all, let's look at that word there, covalent. That's a prefix co. All right, co as in like co-workers. All right. So the idea of valent being the word from the word valence. All right, co-workers kind of work together. Valence being valence electrons. These are going to be valence electrons that work together. All right. And this is a chemical bond between a nonmetal and a nonmetal, which we know nonmetals are looking to gain electrons, becoming more negative, and forming anions. So this is going to be in Earth. First we had a metal and a nonmetal. Now we have a nonmetal and a nonmetal, the third one being two metals. We won't really talk that much about that. It's called a metallic bond. All right, so let's go ahead and get to this, and kind of similar to how we did before, but how the electrons are going to interact is going to be slightly different because this time, instead of having a metal and a nonmetal, we have two nonmetals. So the first thing we need to do is identify, is this an ionic or covalent bond? So I look at my periodic table. Sulfur is a nonmetal, and fluorine is a nonmetal, which means now we know that we are doing a covalent bond. Sorry, I'm losing my voice a little bit here. All right, so let's start with our Lewis dot structures. We know that sulfur has 6 valence electrons. And I know that fluorine, has 6 valence electrons, and so in that case, it is looking to gain 2 electrons. All right, fluorine is in group 7A and thus has 7 valence electrons. All right, which means it wants to gain 1. All right, now, when ionic bonding, this was easy because one was looking to lose and one was looking to gain. Thus, they could form that really strong relationship where both were completely happy. But in this case here, both want the same thing. They both want to gain electrons. All right? But they are also, or even though they both want to gain, they both just really want to be stable in the end. And so in the end, they're willing to compromise. All right? This is what's more realistic in a real relationship, right? Two people want something, and you have to compromise to do that. So what they're going to have to do since they both want something, when two people want the same thing, you end up having to share because, of course, sharing is overrated, but important, all right? Important in life and in electrons, all right? So he wants to gain 2, he only wants to gain 1, so since they both want to gain, they're going to have to share. All right? And the way I like to do is instead of drawing arrows, because one is not giving the electrons away. An arrow indicates that he's giving electrons. He's not giving electrons, but they want to share. And so I like to do that is represent that. There's a couple different ways you can do this. I like to use sharing circles. All right, and I'll show sharing circles as you're going to share these electrons. All right, between them. Now I know what you're saying. It's like, well, wait a moment. He wants to gain 2 and he wants to gain 1. Shouldn't you share like this? The answer is no. This is a no-no. All right. They can only share 1 electron at a time. Or they can only share 1 electron at a time. But they can do it multiple times. But 1 electron, or only 2 electrons, can be in a sharing circle. 2 electrons can be in a sharing circle, 1 from each. So now if I was going to count this fluorine, I have 1, 2, 3, 4, 5, 6, 7, plus it's using this one as well, so 8. So fluorine is happy here. A little smiley face there. Sulfur has 1, 2, 3, 4, 5, 6, 7. He's getting closer, but he's not quite there yet. So just like ionic, I'm not going to bring in another unhappy sulfur. I'm going to bring in another fluorine here. Should have 7 valence electrons. All right, and it's going to share. It's going to share with 2 separate fluorines. Remember, only 2 electrons can fit in a sharing circle. All right. So now this fluorine has 1, 2, 3, 4, 5, 6, 7, 8. He's happy. This sulfur has 1, 2, 3, 4, 5, 6. 7, 8. He has to share with 2 different fluorines to kind of give everything that what he wants in their relationship. All right. And so what we end up with here is we have one sulfur, 2 fluorines. All right. And so we end up with 1 sulfur, 2 fluorines. All right, remember that subscript goes down at the bottom that indicates how many. Remember, there's a 1 right there, but if it's just a 1, we don't have to write it. And that is our chemical formula. All right, that's sulfur difluoride. We'll talk about the naming later. All right, sulfur difluoride. There are rules about which one goes first. All right, it has to do with electronegativities, a topic we're not going to cover in this video. So I always like to give the rule of thumb, or basically the basic rule to follow. The one on the left of the periodic table, more left on the periodic table, will go first. All right. Otherwise, I will help you through that process. All right, because we're not going to talk about electronegativity. All right. Now, since both of these had to share electrons, neither atom, fluorine or sulfur, is getting completely what they want. All right. So these bonds are more flexible, and they're not quite as strong as ionic bonds. All right, these ones are a lot easier to break, which is actually very beneficial in biology. Eventually, when you start talking about things like ATP and mitochondria and cellular respiration, that becomes extremely important to be able to do that. All right, let's try another one. Let's try hydrogen and oxygen here. All right. First of all, hydrogen, remember, it is on the left side of the periodic table, but it is a non-metal. All right. So we have a non-metal, and oxygen is clearly a non-metal. So we have a covalent bond here. All right, so hydrogen is in group 1A, only has 1 valence electron. But remember, it's in the first period, and that first energy level can only hold 2, right? So even though it has a +1, or it only has 1 valence electron, is actually looking to gain 1 more electron. So remember, it can only hold a maximum of 2 hydrogen. All right. Oxygen is in group 6A, which means it has 6 valence electrons. All right, which means it's looking to gain 2. All right. So very similar to before. One thing I want to point out, remember when I first started talking about Lewis dot structures, I suggested that you draw your dots kind of the sides like this, like in order, because now electrons like to work on what we call electron pairs. See how there's a pair there, a pair. These guys don't have a buddy, which means those are the 2 places I'm looking to bond. He doesn't have a buddy next to him. He's looking to bond with somebody. All right. So here, all right, let's make this one happy. He wants to share. We're going to have to share since they are both want to gain. All right. This hydrogen is now happy because he has 1, 2. Good. So oxygen has 1, 2, 3, 4, 5, 6, 7. Because he's sharing that one with hydrogen. All right, he has 7. That's not enough. So we're going to have to bring in another hydrogen. Who's also looking to gain one more. They'll share. All right. Once they've had that opportunity, they've shared those electrons. All right. We have 2 hydrogens and an oxygen. Dihydrogen monoxide, also known as good old-fashioned water. H2O. H2O water is 2 hydrogens and an oxygen held together by covalent bonds because they're sharing those electrons. Okay, so that is covalent bonding. Some of the same principles as ionic, but some very much differences because of the sharing of electrons. Remember, those sharing circles can only hold 2 electrons at a time. Right, 1 from each atom. I can't circle 1 fluorine and then 2 of the sulfurs. Right, I can't do that. All right, it's got to share 1 at a time. It would rather share with 2 different fluorines in that case there. All right, we end up with our different covalent molecules. Instead of ionic compounds, we end up with covalent molecules, which we'll talk more about that going forward. All right, so those are the differences. If you're not sure, you go back and check it out again. Make sure you're feeling very comfortable. Otherwise, good luck, and may the science be with you.